Our solar system is a vast and awe-inspiring place filled with wonders and mysteries. It's filled with planets, moons, asteroids, and comets, each with its own unique characteristics. But at its heart lies a true giant, the Sun, the most important celestial body in our solar system. The Sun is a star, a giant ball of burning gas that dominates our solar system with its immense energy. In fact, it's so massive that it accounts for a staggering 99.86% of the solar system's total mass, an almost unimaginable figure. That means everything else, all the planets, moons, and space rocks combined, make up a tiny fraction of the solar system's mass, almost insignificant in comparison. Imagine a giant pie chart representing our entire solar system, with the Sun taking up nearly all of it. Almost the entire pie would be taken up by the Sun, leaving just a tiny sliver for everything else, a visual representation of its dominance. That's how much the Sun outweighs everything else in our cosmic neighborhood, a true heavyweight champion. This incredible mass is what gives the Sun its immense gravitational pull, holding all the planets in their orbits, ensuring the stability of our solar system. The Sun's mass is not just a random fact, it's the key to its existence and its impact on our entire solar system, shaping everything around it. It's the fuel for the Sun's energy production, the anchor of our solar system's structure, and the source of life-giving energy for our planet, making life possible. The Sun's story begins billions of years ago, long before Earth or any of the other planets existed. Back then, our solar system was just a giant swirling cloud of gas and dust. This cloud, called a nebula, was cold and dark, but within it the seeds of our Sun were sown. Over millions of years, gravity began to pull the gas and dust in the nebula towards each other. As more and more material clumped together, the cloud began to spin faster and faster, and the center became incredibly hot and dense. This process of gravitational collapse is how stars are born. Finally, the pressure and temperature at the center of the collapsing cloud became so intense that nuclear fusion ignited. Hydrogen atoms, the simplest and most abundant element in the universe, began to fuse together, creating helium and releasing a tremendous amount of energy. Nuclear fusion is the process that powers the Sun and all other stars, making them shine brightly in the vast universe. It's the process of combining lighter atomic nuclei into heavier ones, releasing enormous amounts of energy in the process, which is fundamental to the existence of stars. In the Sun's core, hydrogen atoms are constantly being fused into helium, releasing a constant stream of energy that makes the Sun shine and radiate heat, sustaining life on Earth. This process is similar to what happens in a hydrogen bomb, but on a much grander and more controlled scale, ensuring the Sun's stability. The Sun's immense gravity creates the perfect conditions for nuclear fusion to occur, providing the pressure and temperature needed to overcome the electrostatic repulsion between the positively charged atomic nuclei, allowing fusion to happen. The energy released from nuclear fusion in the Sun's core takes a long and winding journey to reach the surface, traveling through various layers. It's constantly being absorbed and re-emitted by the Sun's dense plasma, gradually losing energy and shifting towards the red end of the electromagnetic spectrum, a process known as redshifting. This journey can take hundreds of thousands of years, illustrating the complexity and scale of the processes within our Sun. Section 4. The Sun's gravitational embrace. The Sun's immense mass doesn't just power its energy production, it also dictates the structure and motion of our entire solar system, holding everything together. Gravity is the force that attracts objects with mass to each other, and the Sun's gravity is the strongest force in our solar system, influencing all celestial bodies. It's the Sun's gravity that keeps all the planets in their orbits, pulling them towards the Sun and preventing them from flying off into space, maintaining cosmic order. The planets are constantly moving, trying to move in a straight line, but the Sun's gravity acts like an invisible leash, pulling them into elliptical paths around the Sun, ensuring their continuous journey. The closer a planet is to the Sun, the stronger the gravitational pull it experiences, and the faster it has to move to stay in orbit, balancing the forces. This is why Mercury, the closest planet to the Sun, zips around the Sun much faster than Earth, while distant Neptune takes centuries to complete a single orbit, showcasing the vast differences in their journeys.